In 1905, one man changed reality forever.
The year was 1905. The world of physics was the calm before the storm. But in a small, cozy office, a young man named Albert Einstein was staring at something others simply ignored. A warm cup of tea. Einstein wasn't just looking at the steam. He noticed that tiny particles suspended in the liquid were moving, strangely. Without any clear reason, they were constantly jittering, tossed to and fro in a chaotic, invisible dance. This was a massive puzzle. At the time, scientists were fighting over a fundamental question. Do atoms, actual physical atoms, really exist, or are they just a mathematical ghost? If we dive deep into that teacup, we see this erratic dance more clearly. The pollen grains are like massive rocks, drifting in a vast ocean. But what is pushing them so restlessly? Einstein found the answer. These particles are not alone. They are being constantly bombarded by millions of invisible water molecules. It's like a soccer ball being struck from every side by thousands of invisible tennis balls. The eureka moment had arrived. Through brilliant mathematics, Einstein proved that the invisible was indeed real. He didn't just find atoms, he measured them. With this, the debate was over. Atoms were no longer a theory, they were a fact. A grand victory for science. But for Einstein, this was only the beginning. He realized that everything we see is built from this invisible dance. But soon he would uncover a secret even more shocking. A secret about the nature of light itself. Stay tuned. Einstein just proved the world is made of atoms. But wait, until you see how he discovered that light itself is a deadly weapon. You don't want to miss the next revolution. Hit subscribe and turn on the bell, because part 2 is going to blow your mind. Tone, mysterious and intriguing. Deep in the night, Einstein's laboratory was alive, with a strange violet glow. He was chasing a mystery that would change how we see the light forever. Pause. A mystery hidden within a simple metal plate. Tone. Slightly frustrated and questioning, he turned on a powerful red lamp. It was bright, intense, and flooded the room with waves of light. But, pause, the metal stayed dead. No electricity, no movement. No matter how much energy he poured in, the red light failed. Tone, surprised and energetic. Then he switched to a dim violet bulb. It was weak, barely a glimmer. But the moment it touched the metal, the needle jumped. Pause. The experiment was alive. But how? How could a weak violet light do what a powerful red light couldn't? Tone, educational and calm. To understand, we must look closer, deep inside the metal's heart. Pause. Electrons are trapped there, held by an invisible force. The red light hits them like gentle ocean waves, too soft, too slow to set them free. Tone, high energy, fast-paced. But the violet light, it's different. It's not just a wave, it's a hail of bullets. Tiny packets of energy called photons. One hit, one blast, and an electron is kicked out of its cage at lightning speed. Tone, triumphant and authoritative. Einstein realized the shocking truth. Light is not just a wave. It is a particle. He called them quanta. This simple equation, E equals HF, unlocked the secret energy of the universe. Tone, inspiring and proud. This was the spark that gave us the Nobel Prize and the technology of the future. From solar panels to the cameras in your pocket, we are all using Einstein's light bullets today. Tone, cinematic and mysterious. Einstein had mastered the small, the atoms and the photons, but now, pause. He was ready to look up, to the stars, to space and time itself. The ultimate revolution was about to begin. Fade out, stay tuned for Special Relativity.